Hi, welcome to Electrical Engineering 1 A101CEC. This time, we'll be talking about AC power. We will cover the concept of power in an AC circuit. We will see the difference between instantaneous power as well as average power. We will see the difference between resistive power and reactive power, as well as apparent power and complex power. What is instantaneous power? Instantaneous power is the power at any instant in time. It is the rate at which an element absorbs power. It is calculated by multiplying the current and voltage in its sinusoid form. What is sinusoid form? When we say sinusoid form, it means that the voltage is expressed as a function of time as well as the current. That is, V sub t is equal to V sub m cosine omega t plus theta. And current I, a function of t, is equal to I sub m cosine omega t plus theta. This means that the voltage and current varies in magnitude with respect to time. Instantaneous power has two components. The first one is constant, which depends on the phase difference between the voltage and current. The second is a sinusoid with a frequency that is twice that of the voltage and current. The given figure in this slide shows the possible instantaneous power. The second type of power is the average power. Average power is the instantaneous power average over a period of time. The average power is the component of the instantaneous power that was constant. Let us now differentiate resistive power and reactive power. The resistive power exists when the voltage and the current are in phase. When they are in phase, the circuit becomes purely resistive. Now, when the voltage and current are out of phase, the circuit basically absorbs no power, and it is purely reactive. When the circuit is purely resistive, all the power being dissipated by the source is being absorbed by the resistive part. Now, when the circuit is reactive, although the source is delivering power, it is not being absorbed by the reactive circuit. In a way, this power is considered as wasted power. Maximum average power transfer can also be applied to AC circuit. Maximum power transfer occurs when the load impedance is equal to the impedance of the source. Now, let us talk about effective value of power. Now, what is effective value of power? The effective value of power is the value that a DC current delivers to a resistive load. When a time-varying source or an AC source is delivering power to the resistive load, we want to know how effective that source is on delivering power. Thus, we calculate the effective value, which is the same as what we have said, how much power a DC source can supply to that load. For a DC current, the average power absorbed is calculated as I square multiplied by R. The effective DC current in an alternating source is calculated by the square root of the average of the current square over 1 period. Same thing with the voltage. The effective voltage is calculated as the square root of the average of voltage square over 1 period. The effective values for the current and voltage is also called the RMS value for the current and voltage. RMS means root mean square. The RMS value is applicable to any periodic function regardless of the shape. But since the waveform of interest is a sinusoid, we can say that the RMS value of a sinusoid is equal to the peak value divided by the square root of 2. Thus, the RMS voltage is equal to V sub m divided by square root of 2, and the RMS value of current is equal to I sub m divided by square root of 2. The effective value of power can thus be calculated using the RMS value of current or voltage. The product of the RMS voltage and current is called apparent power, which is affected by the phase difference between the voltage and current. The difference in phase between the voltage and current is being referred to as the power factor of the circuit. Why is it called apparent power? It is called apparent power because it is what the power in the circuit would seem to be, but because there is a resistive and reactive component, not all power being supplied by the source is being absorbed by the circuit. Thus, not all power being supplied by the source is being used by the circuit. There are power that is being considered as a waste. Apparent power is measured in VA or volt ampere to distinguish it from the average or real power, whose unit is watts. The difference in angle between the voltage and current is being referred to as the power factor angle. Power factors affect the way utilities bill for electricity. The power factor can range from 0 to 1 and can either be positive or negative. When the power factor angle is positive, it means that the current leads the voltage, and vice versa for negative angles. Power factor of 0 occurs when we have a purely reactive load. A power factor of 0 means that no power is being absorbed by the circuit. Thus, all the power being supplied by the source is wasted. This means that the source is continuously delivering power which is not being used at all by the load. A power factor of 1 occurs when we have a purely resistive load. A power factor of 1 means that all the power being supplied by the source is being absorbed by the load. A power factor of 1 is desirable, but it cannot be achieved. Why? Because circuits normally have resistive and reactive loads. Thus, power factor will always range between 0 and 1. It is desirable to have a higher power factor because this means that less power is being wasted. A low power factor means that the source is supplying large amount of power, but only a small percentage is being used by the load. Let us now talk about complex power. The term complex power refers to the total effect of the loads on power. The complex power, represented by S, is the total power absorbed by an AC load and is being expressed as 1/2 multiplied by the voltage multiplied by the conjugate of the current I, where the voltage and current are both expressed in complex form. The complex power can also be represented in terms of the RMS values and the load impedance. Thus, the complex power S is also equal to I RMS square multiplied by Z, or V RMS square divided by the conjugate of the impedance. In rectangular form, the complex power S is equal to P plus JQ, where P is the real power and Q is the reactive power, which can either be positive or negative depending whether the load is inductive or capacitive. The unit for the average power or real power is watts. The unit for the reactive power is vars. And the unit for the complex power is Siemens. This slide summarizes how power is calculated in an AC circuit. You can see how the complex power S, apparent power S, real power, reactive power, and the power factor is calculated. Thank you and have a great day. Remember, work hard, work smart, and work your way to your dreams.